Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the feedback or the concurrence regarding the quality of video as well as audio. If it is perfect, just write perfect over the live chat. The agenda behind the series of the engineering mathematics which we have running so far must be clear to all of us. Already 8 number of videos has already been released lively. There we were discussing the basic concept of the engineering mathematics from very scratch. At very first lecture I was discussing about the logarithmic function, and probably the 3 lectures we will spend over the straight line, and we have taken around 5 to 6 crucial problems related to the straight line. Then we went into the trigonometric functions, then we discussed about the circular function, then we discussed about the parabolic function in the last video. In the same sequence, now we are going to discuss one other utterly important function in today's lecture, and that is gonna be absolute function or modulus function. You could have seen many of the times in engineering mathematics or mathematics we come across the situation when we used to have function like mod of x plus 1, maybe mod of sin x, sin of mod of x, mod of tan x, tan of mod of x. So many of the times I have seen the student are not much comfortable with those sort of functions. So the agenda behind today's video has been very precise and clear. We are going into the detailed analysis of the modulus function or the absolute function. Anyways, absolute function is not a prevalent name, but the modulus function is also referred as the absolute function. Absolute function. Could you understand what I am saying? So without getting delayed, let me straight away hop into the working board. So each one of us should be writing. The agenda behind today's video has been very precise and clear. We are going to discuss about absolute function or modulus function. Modulus function. Anyways, how the absolute or the modulus is being referred? It has been referred by the two parallel line. That means the function would be trapped in between the two parallel line. Before going into the detailed study of the modulus or the absolute function, let me focus over what the modulus does. Let me take few number of examples. Modulus, that means it calculates its absolute value. If you take the modulus of 1, the result would be 1. If you take the modulus of minus 1, the result would be just its magnitude or its absolute value, which would be if precisely equals to of 1. Similarly, even the modulus can be taken with a complex number, but as far as this video is concerned, whatever the type of function which we are going to discuss over here, they all will be a real valued function. So in future, even you can take the modula of 1 plus of j. What used to be the module of it? That means the worth of abscissa has been 1, and similarly worth of ordinate has been 1. If you will take its distance from the origin with the help of Pythagoras theorem, definitely you can get its worth. That would be root over of 1 here, which would be equals to of root over 2. But as far as the agenda behind today's video has been very precise and clear, I would restrict myself towards the real valued function. Real valued function. May I know the quality of audio as well as video? Is it perfect or not? Because somewhere it was getting choppy. Anyways, I think it is perfect. So in future, what I am saying, you come across many of the situation, like sometime you deal with the modulus of a straight line, like you might be dealing with the mod of x plus 1. You might be dealing with mod of sin of x. You might be dealing with the integration of mod of tan of x with the certain upper as well as lower limit. You might be dealing with the differentiation of a certain modulus function. Let's take for the time being, it has been mod of x. I know this has been the stale mark for most of the students because they themselves are not much comfortable with the mod of x, and if in the problem the integration has to be performed or the differentiation has to be performed, most of us used to have a lot of pain. So once you are done with this video, I am very sure about it, you are going to deal each and individual problem related to the modulus function very comfortably. Either it's integration, either it's differentiation, either it's a continuity, either it's a differentiability, or whether it is a case of limit existence. Could you understand what I am saying? See, could you understand or not? But whatever the functions which we have taken inside the modulus, they all had been real valued function. What does that mean of it? For all real values of x, x plus 1 is always gonna be real. For all real values of x, sin of x is always gonna be real. For all real values of x, tan of x is always gonna be real. Similarly, for all real values of x, the x is gonna be always real. Even we can deal with some sort of problems like you can have another function where the x has been raised to the power of 1 by 2. This is not a real valued function. Why? Because once you'll keep the negative value of x, by default the iota comes out. So we are not going to deal with this sort of function. So the agenda behind today's video has been very precise and clear. We are going to discuss about the absolute or the modulus function, where the functions at which the absolute or the modular has been applied, they have been real valued function. Real valued function. Could you understand what I am saying? A real valued function. If you want to write, you can write somewhere. A function is said to be real valued function. A function is said to be real valued function. Function is said to be real valued function if it produces always a real value for all possible real values of x, for all possible real values of x. So I would like to ask, x plus 1, has it been a real function? Obviously it has been a real function. Sin of x, for all possible real values of x, sin of x would be in between -1 to 1. Obviously they have been a real function. Similarly, mod of 10x has been a real function. Mod of x or x has been a real function. But I am keeping aside like mod of x, x to the power of 3 by 2, x to the power of 1 by 2, x to the power of 2 by 3. I am keeping all of those functions aside. All of those functions aside. Could you understand what has been the agenda? Agenda has been dealing with the real functions modulus. A real functions modulus. Let me go into the next page. Next page. The first problem which we are going to take, we would learn the basic concept of the modular or absolute with few number of live examples. Let's take, we had to understand the basic concept of the mod of x, and even we had to draw the mod of x over the 2D plane, where the horizontal axis would be dedicated towards x, and similarly vertical axis would be dedicated towards y. For that, what I am going to do over here, let me take a xy plane. Here goes vertical axis which has been dedicated towards y axis, and here goes the horizontal axis which has been dedicated towards x axis. May I know how the mod of x looks like? Keep aside mod of x, just focus over the x. X has been a straight line which passes through the origin and had the slope is equals to a plus 45 degree from positive x axis. So it would look something like this. It would look something like this. It has to cross through origin, and obviously it would make an angle of 45 degree from the positive x axis. Till this point probably nobody should have any doubt as such. Here goes. It has been the function of y is equals to of x. But specifically in this problem, we are focusing over the module of x. What does it mean by the module of x? For all negative values of y, no. You can write mod of x is equals to of y. One thing is quite sure, the y can't be negative because y has been the module of x. Keep in mind, if y can't be negative, what does that mean of it? In between video was getting stuck, probably now each and everything would be very perfect. Anyways, let me come back. So what is happening over here? The curve x has been in the first quadrant, so definitely there would not be any change as such. But as this curve has been in the third quadrant, would get shifted towards the second quadrant. Like at x is equals to of -1, worth was -1. At x is equals to -2, worth was -2. At x is equals to 3, the worth was -3. So obviously the -3 would get shifted towards +3, -2 would get shifted towards +2, and similarly -1 would get shifted to the +1. So end of the day, the curve which we are having, I am going to use the blue curve for it. The angle which we had towards downside, we would be having the same angle towards upside, and now there would not be any change towards the first quadrant. So it has been the curve of mod of x which used to be V-shaped. More precisely, if we'll be discussing about their slopes, may I know what would be the slope over here? Obviously the slope of x used to be 1. Even the slope would have been 1 over here, but as it has been flipped, taking the reference of x axis, the slope would just be reversed. Earlier it was plus of 1, it would be changed to the minus of 1. So from here onwards, whenever I say mod of x, which function must come in your mind? Mod of x has been minus of x. Yes, it has been a minus of x, which has been a straight line crossing through the origin. The value of c would become 0. The slope has been -1. So mod of x would be minus of x for all possible negative real values of x, including x is equal to 0. including x is equals to 0. And even the same fundamental goes towards the positive value of x. As the positive value of x, the y of mod of x remained x because it has been just taken overlapping over the x. So here it becomes x for x greater than equals to of 0. Should I be repeating once again? Yes, I can. Whenever you had to draw a certain modulus function, keep aside the modulus function for the time being, just focus over the functions which has been remained after. It has been y is equals to of x. How would be the structure of y is equals to x? Y is equals to x would be a straight line crossing through the origin and would have the slope is equals to of 1. That is why the green curve has been used, which was crossing through the origin and had the slope is equals to 1. Now it's the term to take modulus of it. What does that mean by the modulus? That means the y has to be ensured as a positive. Y was already positive, there would not be any change. That is why for all positive value of x, y has remained as x itself, which was the outcome over here. But towards the third quadrant, the value of y was negative. That is why it was flipped taking the reference of x-axis, and hence the slope just got reversed. Initially the slope was +1, has been changed to the -1. So from here onwards, whenever I say mod of x is equals to, obviously can be distributed into two different functions, where for negative value of x it has been defined as a minus of x, and similarly for the positive range of x it has been defined as plus of x. So probably till this point each and everything must be clear to all of us. Alok Kumar, when the engineering mathematics will start, my dear friends? Probably for tomorrow, from tomorrow onwards, and even the questions which I used to take, which have come from the very basics of the engineering mathematics, they are related to the same concept only. You can't say from where the engineering mathematics would start. The problem have coming repeatedly from this domain of engineering mathematics. So you can say already the basic part of the engineering mathematics has been running. Similarly, if we'll move ahead, if I take another function, again it has been a type of modulus function, mod of x plus 1. How it would look like? Let me take a 2D plane. It has been a vertical axis, it has been a horizontal axis. Here goes the x-axis, here goes the y-axis. Forget about the modular ones and just focus over y is equals to of x plus 1. May I know how would be the structure of y is equals to x plus 1? The x is getting multiplied with 1, that means the slope is going to be precisely +1. What does that mean by the +1? As the value of x would increase, the value of y would be increasing, that's fine. And even the value of c had been 1. What does that mean of it? That means the intersection point over the y-axis is going to be at 0,1. So obviously the intersection would be at 0,1 and slope would be positive. So let me draw this, how it must be looking like. It must be looking something like this. And if you'll be focusing over its slope, obviously the slope had been plus of 1. Just a minute. Slope had been plus of 1. Now again, the time have come, we had to take its modulus. What does that mean by the modulus? The value of y has to be always and always positive. As far as this point is concerned, if you go towards right hand side of this point, the y has always been in first as well as second quadrant, the value of y has been positive. But once you go towards the left hand side of this point, what is happening over here? The function had the negative value. So what you would do, you would just shift this function taking the reference of x-axis and it would go towards upside. So let me change the color a bit. Earlier also I used the blue pen, now also I am using the blue pen. So it's going to be the structure of mod of x plus 1. May I know what was the slope earlier? Slope was 1 over here, and yes, the slope would also be 1 over here. Once we flipped this structure taking the reference of x, what would happen? The slope would just be reversed. Earlier it was plus of 1, it would be minus of 1. You can see very well, no? The plus slope is going to be 1 over here, it's going to be simply minus 1 over here. Earlier it was striking towards 0,1, and similarly if we allow this function to strike towards the y-axis, it would strike over the y-axis at y is equals to of minus 1. So again the same concept we can use which we have been using earlier. Mod of x plus 1 can be distributed or can be divided into two parts. Because the function has not been the continuous, or function has not been the uniform throughout the range of x. Before this point it has been a different function. Obviously it has been a line which had the slope is equals to minus 1 crossing through the point c is equals to of minus 1, and similarly after this point the straight line had been a straight line which had the slope is equals to +1 and cosine to the 0, 1. Obviously, it had been the two different straight lines and they have been valid for a certain range of x. They have been valid for the certain range of x. May I know what is this change point? How will you know about this change point? This was the point at which the value of function was getting 0. Because if you will take the reference of 0, sometime it may go greater than 0, sometime it may come lower than 0, and hence here the change point was what? So here how the change point would be known? Whenever you had a function, the modulus has been taken for the function. If you really want to know the change point, what you had to take? You had to take the relationship of the function with 0, and once you take the relationship of the function with the 0, you get the worth of the change point. You get the worth of the change point. The worth of the change point has been x is equals to of -1. That means this function has to be written, or this function has to be distributed taking the reference of x is equals to of -1 towards negative value of -1 and towards higher value of -1. You would be having the two different natures of this straight line. Let me focus over the lower value in compare with the -1. It has been a straight line having slope is equals to of -1, and similarly it has been crossing through the y-axis at c is equals to of -1. So as per the straight line's equation, y is equals to of mx into c. M has been -1. -1 is getting multiplied with x. Obviously it would become minus of x, and now it's going to strike at c, and the c has been -1. So simply it's going to be minus of x minus of 1, minus of x minus of 1. Similarly, if you will take the reference of a straight line, which has been the straight line after x is equals to of -1, it would simply become x plus 1, because there was no change. Whatever the straight line which we have drawn earlier has been the same one, Could you understand what I am saying? So from here onwards, at least one important conclusion we can retrieve. If you have a function mod of x plus 1, that means the nature of this function would change at its critical point. May I know how do we get the critical point? Just you have to compare x plus 1 is equals to 0. And if you compare x plus 1 is equals to 0, definitely we get the value of x is equals to -1. So the -1 is going to be the critical point here also. Either you can take the reference where the x has been lesser than -1, and similarly in second span, the value of x has been greater than of -1. If you take the range when the x has been lesser than the value of critical point, the value used to be the multiplier of -1 towards x side as well as c side. So simply it becomes minus of x minus of 1. And if you go beyond the critical point, the function remains as it is. Could you understand what I am saying? Although I have taken the reference of mod of x plus 1, but in future you can take the reference of mod of ax plus of b, where the a and b are the real coefficients, can be positive or even can be negative. Could you understand what I am saying? I have seen many of the times when specifically we deal with the continuity, discontinuity, limit existence and differentiability. This is the point where most of the students do get stuck. So let me take another problem. For the time being, I have taken a broadest form of absolute function, without drawing or without sketching its xy planes curve. May I know what would be the critical point, taking the reference of which it would get distributed as a two different straight lines? That's the first thing. Secondly, what would be the nature of the function towards the left hand side of the critical point, and similarly towards the right hand side of the critical point? Tell me. What we had to do? We had to just compare ax plus b is equals to 0. So the value of x which have come in mind is simply going to be minus b by a. The one span would be the span of x when the x is lesser than equals to of the critical point, which has been minus b by a. And similarly, the another span would be the span when the x is greater than equals to of the critical point, which has been minus b by a. When the span has been lesser than equals to of critical point, what we do? We multiply with the minus sign with the first as well as second component, or put together this complete function gets multiplied with the minus sign. So the result what we are getting as a function is simply going to be minus of ax minus of b, and here it remains same as the old function, which had been ax plus b, ax plus b. You yourself would be able to analyze this. Yes, when we were taking the modulus of x plus 1, at very beginning we were talking about its critical point. What I did, I took the comparison of x plus 1 with 0. The value of x which came in my hand is simply going to be minus of 1. So minus of 1 was the critical point. Now at the critical point, the equation of the straight line is going to change. What are the different changes we are experiencing? First change. Earlier, if the slope was m, now the slope would become minus of m. What does that mean of it? Earlier, if the x had the multiplier as a, now it would become minus of a, because the a was the slope of this straight line. Minus of a is nothing but a new slope having just multiplication with the minus sign. Just multiplication with the minus sign. Yes, that has happened. Not only that, earlier if you will take the reference of this straight line, it was crossing through 0 comma c, but now it is crossing through 0 comma minus c. That means the m has multiplied with minus, and similarly c has got multiplied with the minus. Put together, for x lesser than equals to of critical value, it's simply going to be minus times of x plus 1, which is very same as minus x minus 1. And similarly, if x is greater than equals to a critical point, it has been simply x plus 1 alone, x plus 1 alone. So just wanted to know from each one of you, could you understand till this point? Because this is a point where many of the students do have sort of doubt. So let me take few more number of examples. Let's take, I have taken a problem of mod of 3x plus of 2. Mod of 3x plus of 2. How it can be written into the two different forms of the straight lines. At very beginning, we are focusing over its critical point. How will I get the critical point? 3x plus of 2 has to get compared with 0. The 2 goes through a right hand side, would become minus of 2 and gets divided with 3. So obviously, you would take the reference of x is equals to of minus 2 by 3. So you would be having the 2 span when the x was lesser than equals to of minus 2 by 3, and similarly x is greater than equals to of minus 2 by 3. If x has been lesser than the critical point, the minus would get multiplied. So simply it becomes minus of 3x minus of 2. And here it becomes plus of 3x plus of 2. The function would remain as it is. So far we are not going to discuss about the limit, continuity and differentiability, but still you can have a fair idea. The function would not be differentiable at x is equals to 0. Why? Because there was the formation of cusp over here. What does that mean by the cusp? Cusp means choti in Hindi. That means you cannot draw a unique tangent over this point. For drawing a tangent, the curve has to be smooth at that point, and it has not been smooth, and hence it won't be differentiable. So if I say modulus function, at which particular point the modulus function fails to provide the differentiability test, obviously at its critical point. As for the mod of x, the critical point has been x is equals to 0. Similarly, if I take the next problem, I would ask at which particular point mod of x plus 1 would not be differentiable. It would be the point at which the cusp has been formed. May I know where exactly cusp is getting formed? The cusp is exactly getting formed at point where the changing has been taken place. And where the changing has been taken place? Again, x plus 1 has to get compared with 0. The value of x has been minus of 1. Value of x has been minus of 1. Minus of 1. Similarly, if I take the problem like ax plus of b, if I have taken its modulus, may I know precisely at which value of x the function won't be differentiable? At its critical point, which has been minus b by a. Similarly, if I have taken another function 3x plus of 2, if I would like to ask from each one of you, the function won't be differentiable at which precise value of x, you had to calculate its critical point, and that has been 3x plus 2 is equals to of 0, x has been minus 2 divided by 3, minus 2 divided by 3. Yes, Ayan Mandal states minus 2 by 3, that's perfect, So would like to ask from each one of you, till this point each and everything is clear or not? Probably it must be clear, So we were talking about the modular function of the linear or straight function. Let me move ahead. If I have taken a function f of x which had been mod of x divided by of x when x was not equals to 0 and 1 for x is equals to 0. May I know how this curve would look like? I would repeat once again. We have been dealing with a function f of x is equals to of mod of x divided by x, and this function was precisely defined when the x was not equals to 0, and precisely at x is equals to 0 the worth of the function had been 1. Would you be able to draw over the xy plane? Let me try it out. Let me take the xy plane over here. Here goes the horizontal axis, here goes the vertical axis. This has been x is equals to of 0 axis. At y axis the worth of x used to be 0, and similarly over the x axis the worth of y used to be 0. So the worth of the function has to be asked by mod of x divided by of x only and only all of the points of x except x is equals to 0. That means you cannot choose the value of y. You cannot choose the value of f of x over the y-axis, neither here nor here nor here. That has to be exclusively decided by 1. So at x is equals to 0, the function had been 1. Function had been 1. Let's take it has been dot over here. What's the worth of it? It's 1. It's 1. May I know how the mod of x divided by x would look like? My dear friends, if you'll go further, mod of x had the bifurcation. Mod of x had been minus of x for the x less than equals to of 0, and similarly mod of x had been mod of x had been what? Plus of x for x greater than 0. So what I am going to do over here, mod of x divided by of x was bifurcated into the two different regions. First x lesser than 0 and next x greater than 0. When the x is less than 0, which we have seen earlier, mod of x would be dealt as a minus of x. Minus of x gets divided with the x, it would be simply minus of 1. And similarly, if I take the reference of the x where the x has been greater than 0, mod of x would be treated as x alone, x divided by x would be simply equals to plus of 1. That means for positive value of x, it would be treated as plus of 1, which would be a DC component. Similarly, for negative value of x, it would be treated as minus of 1. So how the curve would look like? The curve would look something like this. Which type of function it is? It has been a Signum function. If you really want to write this, obviously it's gonna be a Signum function. It has been a Signum function, and precisely at x is equals to 0, the worth of the f of x has been plus of 1. That is why the dot has been taken over here and whole has been taken over here. Let me change this problem a bit. F of x is equals to, rather taking mod of x divided by of x, if I have taken the ratio between x divided by of mod of x, which has been precisely defined anywhere except x is equals to 0, and 1 at x is equals to 0. May I know the curve over the 2D plane, would it be same or would it be different? Whether both of them are representing the same function or whether they are representing the two different functions. They are representing the same function. Although when the x has been taken less than equals to of 0, mod of x was becoming minus of x at numerator, but here it would become minus of x towards denominator, but still once you will take its ratio, the ratio would remain minus 1 for all negative value of x. Similarly, if you take x greater than equals to of 0, earlier mod of x was becoming plus of x towards the numerator side, but still it was getting divided. The worth which was coming in our hand was plus of 1. Here also it would be plus of 1. So more or less there would not be any change as such. Either you take mod of x divided by of x, whether you take x divided by mod of x, barely it makes any sense. They are utterly same. Now I would like to ask another function. The function has been, let's take another function. The function has been max between the two functions, and they had been x and minus of x. Once the problem have come based on this concept, probably in mechanical around 5 to 6 years back. May I know how this curve would look like? Max of a function x, comma, another function minus of x. Like we do the calculation, no? Max of 2 minus 2. May I know what would be the max between 2 to the minus 2? Obviously, the 2 has been a larger value in compared with the minus of 2. So obviously the worth would be 2. In the same way, we are going to have the output as the maximum value between x and minus of x. Just wanted to ask from each one of you how this function would look like. Max of x, comma of minus of x. If you observe this function carefully over the xy plane. It has been the x-axis, it has been the y-axis. Just focus over the first function first, which has been x. May I know how the x looks like? Obviously, it has been a straight line, would have slope is equals to +1, would cross through the origin, So how it would look like? This has been x. Similarly, if you had to draw a straight line, y is equals to of minus of x. Again, it would be a straight line, would have the slope is equals to of -1, and as the value of c has been 0, it would be crossing through the origin itself. So it would be sort of this. At any moment of x, the worth of the function which has been defined as the maxima between the two functions, which has been x as well as minus of x. So may I know at x is equals to, let's take at -2. What would be the worth if I take the reference of minus of x? Obviously, the worth would be plus of 2, and if I take the reference of x, the worth would be -2. Similarly, if I take the reference of f1x at x is equals to -3, the worth would be -3, and here it is gonna be +3. Sorry, -3. Similarly, at +1, it becomes plus of 1, it becomes minus of 1. At -2, it would become, at +2, it would become plus of 2, and it would become minus of 2. Yes. You had to take the maximum value at any moment of x. May I know, at x is equals to minus of 2, the maximum value would be chosen with the help of this straight line or this straight line. Obviously, we had to choose using this straight line. Because if you take the reference of function minus of x for all negative value of x, the value of the function is going to be positive, which is going to be greater than the function fx is equals to of x. So as far as the negative range of x is concerned, the max of x comma of minus x would be very same as minus of x itself. So you can see it is like this. And when you go for the positive value of x, whenever you go for the positive value of x, you yourself would be able to understand, if you calculate the maximum value of the function at x is equals to 1, may I know where the maximum value has been prescribed? Obviously, it has been prescribed by the function x itself. That means for positive value of x, the function would be prescribed by plus of x. So more or less, you have been dealing with the same concept. Max of x comma minus of x is very same as mod of x. I would like to ask from each one of you, could you really digest this concept or not? Because 5 years back, the problem were come based on the concept, based on this concept. Could you understand from where this concept have derived out? The max between x comma of minus of x is simply equals to of mod of x. Let me ask one next question. We had the two functions x and minus of x. If I have designed a function which has been the minima between x comma of minus of x, which type of function it would be? I would like to have the input from each one of you. How the minima between x comma of minus of x would be looking like. That means at x is equals to of -2, if you had to take the minimum value, obviously that minimum value has to get selected by this straight line. Similarly, at -3, this minimum value has to get selected by this straight line. May I know which straight line it has been? It has been plus of x. And similarly, when you will go towards the positive value of x, and still you have to select the minimum value, from where the minimum value has been extracted out, obviously with the help of a straight line which has been precisely defined as a minus of x. So minima of x comma of minus of x can be written as plus of x when x is less than equals to of 0, and minus of x when x is greater than equals to of 0, which can be simply written as minus of mod of x. Yes, because the minus sign got multiplied towards the lower range of x as well as the upper range of x. So in future, you need not to have any doubt over this sort of function. Could you understand, each one of you? Could you understand this? So probably nobody should have any doubt as such. In the same sequence, let me move forward. If I take the next function, which function it could be? I need to take the integration of mod of sin x. Deliberately, I have designed a problem based on the integral calculus, because until and unless you do not have the fair idea about the modulus function, you are going to be in big trouble while doing the analysis with the integral function. Yes, Alok Kumar, that's fine. Mod of sin x dx. And let's take the integration has been taken place from 0, you can take till 3 pi by 2. How will you do its integration? See, whenever you deal with the modulus function, no, just have a bit understanding how the modulus function would look like over the xy plane. How it would look like? Let me take a reference of xy plane. It has been the x-axis, it has been the y-axis. How the sign of x looks like? The sign of x used to be a pure oscillating signal, where upper peak would go to the +1, lower peak would go to the -1, and obviously its time period would be 2 pi in radians. But once you take its modula, what does it mean by the modula of sin of x? That means for any possible values of x, mod of sin x can't be negative. Already this lobe of the sign of x was in the first quadrant, there would not be any change, but this lobe of the sign of x have come into the fourth quadrant, definitely would be multiplied with the minus sign. It has to go up, all the way it has to go up. There would not be any change till 2 pi to 3 pi, but again if you take the reference of 3 pi to the 4 pi span, it would again be going up. So may I know what is the nature of the sinusoidal function in between 0 to pi? It has been simply sin of x. But now if you will be discussing about the nature of mod of sin x in between pi to 2 pi, it has been minus of sin x. Similarly, in between 2 to pi to 3 pi, the nature of mod of sin x has been simply sin of x. And from 3 pi to the 4 pi, it has been minus of sin x. Could you understand what I am saying? So if you're really interested in finding the integration of mod of sin x from 0 to 3 pi by 2, you had to break the integration in parts. From 0 to pi, one thing is quite sure, the mod of sin x has been uniform in nature and which has been defined as the sin of x itself. So you would be taking the integration of sin of x from 0 to pi plus, but from pi to 3 pi by 2, where the 3 pi by 2 would come? Obviously, 3 pi by 2 would come somewhere here. The nature of mod of sin x had been minus of sin x. So you can take minus of sin x d of x, or the minus sign can be brought it out, the plus and minus would get multiplied and it would simply become minus of sin x. Choice is yours. And I have seen in past few years, this sort of problem have repeatedly been asked. Yes. What they would do, deliberately they would design a function which would be a type of modulus function, and then they would ask you to get the area under the curve. And what the people would do, the student who are not having the good idea about the modulus function, or if they are not having the good idea about the modulus function over the 2D plane, simply they would remove that mod and they would take the integration in ones through from 0 to 3 pi by 2. From 0 to pi, if you are taking the integration once through, that looks okay because the function has been uniformly same as sin of x. But from pi to 2 pi, it has been minus of sin x. That is why the integration has to be done in parts from pi to 3 pi by 2. And that integration you can do by yourself. Is sin x and minus? No. Alok Kumar is saying, sir, is mod of sin x minus of mod of sin x? No. May I know how the minus of mod of sin x would look like? Let me take the reference of it. Again, I have taken a xy plane. Here goes the x-axis, here comes the y-axis. How was the structure of the mod of sin x? Each and individual lobes were towards upside. But now exclusively it has to get multiplied with a minus sign. Whenever any of the function or any of the signal gets multiplied with a minus sign, there would be folding of that signal taking the reference of x-axis. That means all of the lobes were fabricated towards upside, now would be fabricated towards downside. How would be the structure? Structure would be sort of this. Structure would be sort of this. Here goes 0 radian, here goes pi radian, here goes 2 pi radian, here goes 3 pi radian, 3 pi radian. In between 0 to pi radian, the function would be defined as minus sign of x. In between pi to 2 pi radian, the function, again if you'll recall the actual sign of x, in between pi to 2 pi, there has been the problem in between, but now I don't find that any problem you guys would be having. The quality of audio as well as video must be smooth now, Till this point, each and everything must be very clear to all of us. Now let me move forward. Into the next concept. May I know what concept it could be? Let me focus over the differentiation. For the time being, I have taken the differentiation of a modulus function. It has been mod of x. May I know how the differentiation of mod of x would be taken place? Mod of x can be taken as minus of x for the x less than equals to of 0, and similarly plus of x for x greater than equals to of 0. Now if you will take the differentiation of minus of x, definitely it would be minus of 1, and similarly if you will take the differentiation of plus of x, it would be plus of 1. So as far as the differentiation of mod of x is concerned, it's gonna be a properly Signum function. Could you understand what I am saying? Should I be repeating once again? Mod of x can be taken as minus of x, plus of x for x less than equals to of 0, x greater than equals to of 0. Separate differentiation has been made over here. So the result what we are getting is precisely going to be minus of 1 and plus of 1, and here this was the value when the x was less than 0, and it was the value when the x was greater than 0, and obviously the mod of x would not be differentiable at x is equals to 0. Yes. Now I can design a mathematical tool to take the differentiation of any modulus function or the function which contains a modulus part. Can't I write mod of x as root over of x square? Obviously yes. Which is a type of root mean square. I have taken its square first and then we took its root over. Once I am taking its square, definitely the value becomes positive, and the square makes it the square of the older value, and again the square root snatches that worth of squaring, but still the result has been positive. So what I am going to do, rather writing mod of x, can't I write mod of x as the root over of x square? Obviously I can. Now I would be differentiating root over of x square. Once I differentiate root over of x square, at very beginning it has been x to the power of 2 to the power of half. Yes, it has been x to the power of 2 to the power of half. Now nobody should cancel this half and 2. It can't be. So at very beginning, if I'll take its differentiation, the half would come out. Yes sir. And here if you will take x squared to the power of half would get subtracted with a minus 1. So end of the day, result what you are getting is going to be x squared to the power of minus half, which can be simply written as root over of x square. And at last I would be taking the differentiation of x square which had been 2 of x. This 2 and 2 is going out, and it has been x divided by of root over of x square. Root over of x square was written in place of mod of x. So end of the day, a result what you are getting had been x divided by mod of x. And yes, you had the calculation of that only. Even while doing the differentiation by parts, I was getting the same output. So what I would suggest, in future, whenever you are dealing with a certain function which had been a precise modulus function, or that function contains a part of modulus function, what you can do, the part of modulus function can be dealt as a RMS. And once you have been dealing with the RMS, end of the day, you can get its differentiation very well. Once the problem have come in civil engineering, probably 10 years back. Let me take another problem. the problem had been 1 divided by of 1 plus of mod of x. My dear friends, there had been the problem or glitches in between. So what we are going to do, we are going to interrupt this video here itself, and from tomorrow onwards I would continue from the concept of modulus function again, and we are going to take around 6 to 7 important number of questions which have appeared in GATE examination. So probably we had to stop my video here itself, and we would be meeting with the same agenda and same motive precisely at 9 p.m. till 10 p.m. where I would be discussing about the different kinds of the modulus function, and I would be discussing about its differentiation as well as integration. But this is all about today's lecture. If you guys wanted to give certain sort of feedback, you can just put that feedback over the live chat, so at least I'll try to incorporate from the next video onwards. This is all about the today's video. In tomorrow's video again we are going to discuss about the modulus function and the problem related to the modulus function. Till then, bye bye, take care, and most importantly, do the preparation up to the great extent. Bye bye.